Welcome to my video on 3 ways to conceptualize the meaning of fractions. Have you ever wondered about what does a fraction mean and how can I visualize it in 3 different ways? Well, that's what we're going to talk about. So our first method is going to be called the discrete method. We're going to use the discrete model to represent fractions. So let's take the fraction 3/5. Remember that our meaning of fractions, we want to decompose 3/5 into 3 times 1/5, which will mean 3 groups of size 1/5 of some whole. Okay, so we have to define a whole. We have to find 1/5 of the whole. Then we have to iterate 3 copies of it. So I have iterated 3 copies of size 1/5. So let me show you what I mean. Let's say my whole consists of 5 different circles. That's like a very common way to talk about discrete items. And remember, something is discrete if they are separate, non-touching objects. So I have discussed what my whole is. This is the whole group. Let's say this has, it is a pea, and there are 5 different peas in this pod. So if we want to represent 3 of the 1/5, I would shade in 3 peas of size 1/5. So you see 1/5 is just iterated 3 times. So that's how we can use the discrete model to think about the meaning of a fraction. Next, we will shift to an area model. Now you might be saying, well, I've thought about area models before, and that's exactly right. We've used an area model so much in this class. It's a very important tool. So let's say I wanted to talk about the fractions 5/6 this time. And again, let's ask ourselves, what does this mean? Well, it means 5 copies of size 1/6. 5 groups of size 1/6 of some whole. So a very common shape that's used for area is this rectangle. So just like last time, we had to define what our whole was. So I'm going to say this is our whole. Next, we need to partition it up into 6 equal pieces. And my favorite way to do that is to use number theory. So 6 is 2 times 3. So how can I use that to help me partition? Well, I'm going to partition 6 into 2 equal groups, and then I'll partition each of the halves into thirds. So I have 6 different pieces, and they're all equal, and they're all of the same whole. So I've shown sixths, and now these are all size 1/6, and now I just need to communicate, well, how many of them do I mean? Well, I think we said we wanted 5. So 1, 2, 3, 4, 5. So altogether, the yellow represents 5/6 of one whole. And that's another way to conceptualize the meaning of 5/6 using the area model. Our last model or method is one of my favorites. There's something about the number line that's very nice to work with in mathematics. So we know our number lines, it can be empty. We don't have to put all the numbers on there, but we use the numbers that will help us make sense. So let's say I wanted to model the fraction 8/3. Just as before, we are trying to decompose this into 2 factors, so this can be thought of as 8 groups of size 1/3. 8 groups of size 1/3 of some whole. Turns out that whole is really important, which is why I keep writing it. So what we first need to do is identify a whole. So I'm going to say the whole is right here, and I'm going to write whole. So I take my whole and I decompose it into 3 equal parts. I'm going to use a different color. And there we go. Then we have our thirds that show up. So here's 1/3. If I concatenate another third, that brings me up to 2/3. And if I concatenate or add head to tail another length of 1/3, that gives me to 3/3. So I need to keep going up because I want 8/3. I don't just want 3/3. So let me add another whole, and I know to decompose that into 3 equal parts. And that will bring me another third, another third, another third. And if I keep counting, that's 4/3, right? 1, 2, 3, 4/3, 5/3, oops. And then 2 is the same thing as 6/3. And we need to keep going, so let me decompose another whole into some 3 equal parts. And here we go, 7/3, then 8/3. So that's what we wanted. What's important with number lines is to show visually that 8/3 is the same thing as the length from 0 to 8/3. So this is how we can display a fraction as a point on the number line. So here is the point on the number line, and you can see the length it has, which is size 8/3. We also know this is 2 2/3, which is a really nice thing that our model shows us. I can see that I have 1 whole, I have 2 wholes, and I have 2 additional thirds, which is the same thing as 2 2/3. The last method I want to show you, you get a bonus here, is called the tape diagram. And the tape diagram is kind of neat because it's a mix of a number line and the area model. And it's important enough to just state it here because it's strips of paper. Oftentimes we see strips in different areas. So let's say I wanted to model the fraction 7/4, which again, we want to visualize that as 7 copies of size 1/4. 7 copies of size 1/4 of some whole. Okay, so just like before, we need to decide, well, what is our whole? Because I need to find 1/4 of it. And I'm going to decide that my whole is from here to here. So here's 0 to 1. Again, this is my whole. And we need to partition it into 4 equal parts because that's the meaning of size 1/4. 1/4 results from dividing some whole into 4 equal parts. So if we count by fourths, we can say 1/4, 2/4, 3/4, and then 1 is the same thing as 4/4. But we're not quite up to 7/4, so let's iterate some more copies of size 1/4. I'm going to decompose another whole into 4 equal parts. And I'm going to put the lengths of size 1/4 written down. Let's see how many I need. 4/4, 5/4, 6/4, 7/4. There we go. Just like last time, I need to shade in how much is actually 7/4. So it's a bit, looks like an area and also looks like a length at the same time. So here's 7/4 of some identified whole. I hope all of these methods, the tape diagram, a number line, an area model, and a discrete model, helped you make sense of 3 different ways to conceptualize the meaning of fractions.